Let's take a look at what we have so far. So I'm just going to just set a breakpoint at the beginning of our main procedure and make sure that everything is built, which it is, and then say debug, start debugging. So we're making stop at this breakpoint. Let's go again display our registers, because we're really we can only see so far results in our register window. We're not displaying anything in this program, so we're just going to step over. So right now EAX contains the address of hello bytes. Then we're going to save this on the stack. Now notice that as soon as we push EAX, ESP register is going to be decremented by 4, because this will be taking up 4 bytes on the stack, and the ESP will be decremented by 4 bytes. So we just step over push, and there you go. So it's just like changed to over here to 0, which is 4 bytes less. And now we're going to call strlen. Okay, so we're just going to step over it, and of course register EAX upon return. And by the way, all standard library functions and API interface of operating system, whenever there is a return of an integer result, is going to be in register EAX. It's just part of most of the calling conventions and library design. So this is why EAX is going to be populated here. So we're going to say F10, and you can see that it's equal to 5, which is correct. So now we're going to maintain stack. So the stack will be incremented by 4 over here. I step over, you see that it got incremented by 4, which is the original value of our stack pointer upon entry into our main procedure to begin with. So now we should be ready to return safely and nicely from this program. I'm just going to verify by saying debug, continue. So if I continue my program, it just exits nicely with code 0. So everything looks good. Now let's add a call to strncpy. Okay, so strncpy copies specified number of characters from source memory to the destination memory. Okay, so we have a call to strncpy. We're going to say call, and what call is requiring. Let's just add some comments right here and say prepare to call strlen. Okay, so this will be a little comment right here at the top. Okay, let's close this to make more space. And now we're going to say prepare to call strncpy. So you see that strncpy requires 3 parameters: the length, the source, and destination. And this C standard library, the C calling convention for functions, part of C standard library, requires that parameters on the stack, of course, just like we did with strlen, must be placed on the stack from right to left. So therefore, the length parameter needs to be passed first. So we're going to repeat this, right? So this is how many characters to copy, right? So this is the rightmost parameter, and we have to push it first. It really is specific to the calling convention of C standard library, and that's what it wants. It wants the parameters to be passed from right to left. So the next one, we're just going to do very simple steps like we did here. So we're going to push source, right? Again, I'm going to load offset of source into EAX and push EAX. So this will be address of the source string, right? And likewise, I'm just going to copy and paste it one more time, and this time we grab the address of the destination string. So I push it, and of course I push it here because I already have it in EAX, right? The result, the length of our string is already in EAX. That's why how many characters to copy is going to be using this push instruction. All right, so then address of the source and address of the destination we call strncpy. So all of these three push instructions, let me just highlight this push instructions in my code. When we do this preparation to call strncpy, they're all going to be placed, all of these three parameters are going to be placed on top of the stack. And this is where strncpy is going to find the parameters that we're trying to give this C library function. So if we want to count all the bytes, each EAX that we push, each value that we push over here, is of course 4 bytes in size. So we have 3 of them, so altogether, right here, we've used 12 bytes on the stack. And once again, we have to maintain our stack, and I'll just copy and paste this one more time. So this time we need to add 12 to stack pointer to remove all the arguments, because C library does not remove arguments from the stack. We have to do this manually. So I'm just going to do it the same way, but it's one of the important things to keep an eye on when you're using it. It's incredibly straightforward. It's just really like what kind of parameters. You just grab all the parameters, push them on the stack in the correct order. You need to know which order you're supposed to follow, and then the final thing is that you need to remove the parameters from the stack. Okay, so this is how you deal with C standard library. And let's run this program. I think that's all we need to do to demonstrate that we can indeed call strlen and strncpy. And let's just do it one more time. Build, make sure that everything is okay. And one more time, start debugging session. Okay, so we're going to just step over this, F10, 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 and of course this is the length of our source string, hello, 5 characters, and then we're starting to push our characters, and I'm just going to step over everything, and I'm just about to call strncpy. So let's display the destination, the content of our destination again in the immediate window. I'm going to say clear all, question mark, ampersand destination, and this is the area in memory. If I switch over to this memory, copy and paste this address, hit enter, this is our destination, and this is how it looks like. I believe we reserved 80 bytes over here. I don't care, I'm not going to count them. It's just that I know they're here. So now the next step is of course to call strncpy and step over it, F10. And so here you see that the bytes were updated, and of course hello just appeared as a result of strncpy in the expected destination right here. So then we have still to maintain our stack pointer, and this is our stack pointer right here, and we're just about to add 12 bytes to it, which removes previously pushed elements on the stack. So we're just going to step over this, F10, and now we're back to the original value of our stack. And if we just say debug continue, we should exit our code nicely without any unusual exceptions or anything else. So I'm just going to do this. You see that we're just exited very nicely from this program. So this is so far our prototype, and with all of the steps outlined in this lab, now you know that you can indeed write code which can be now pretty powerful, because you can call C runtime standard library functions from anywhere in your assembly code.